Hello and welcome. It gives me a great pleasure to introduce this lunchtime lecture. This week we're joined by Professor Simon Pearson, MBE, founder and director of the University of Lincoln's Lincoln Institute for Agri-Food Technology, or LIAT for short. I've been lucky enough to interview Simon for the Brash Ag podcast, and to say he has a wealth of knowledge and insights is a serious understatement. Simon's career cuts across every part of the ag tech and agricultural engineering system. So everything from a vegetable farming family in Lincolnshire and a childhood involved in that, to glasshouse engineering and patents at the University of Reading, global supply chains and technology leadership at Marks and Spencer, and building one of the UK's most influential ag-robotics ecosystems at the University of Lincoln. In 2025, Simon was awarded the IAgrE Award of Merit in recognition of his contributions to agricultural engineering and technology. His work focuses on the development of AI in Agri-Tech, automation of farming, and digital assurance. With a string of startups under his belt as well, working with some of the world's pioneering agricultural robotics companies, Simon couldn't be better qualified to deliver this lecture on the topic of from robots to returns. So with that, I'll hand over to Simon.
Oh, thanks, Ray. That's brilliant. Yeah, I've forgotten I've done all that. I think in this job you've got to be a bit of a goldfish, and you've got to wander around and then forget, and then you keep going on, don't you? Yeah. Thanks very much for inviting me to the lunchtime session. I'm going to try and give a bit of an overview of a bit of robotics, where it's going, and some of the commercialization opportunities. So what I thought I'd do is just give an overview of the sort of stuff that we're doing at the moment at LIAT, and some of the sort of commercialization stuff that we're trying to do. Just as a bit of a background, why are we focusing still on Agri-Tech? I still think it's incredibly important. I get involved in quite a lot of policy stuff, and I mean, it's pretty clear that the amount of money coming into agriculture and the government is declining, and I can't see that personally. I can't see that changing over the short to medium and even long term. And I think what that really means for all of us and all farming companies is that it's an absolute laser focus on productivity. So trying to get more out of less, continuously. And that actually has been the story of farming really since it started. And why is that? And what are the areas that we've particularly focused on at Lincoln in terms of our own ag tech? Well, I put three little diagrams here. One is a picture of a daffodil picker in Cornwall. I'm particularly close to this one. I was CEO of a company called Winchester Growers. We had 900 people picking daffodils. I think it was about 7.5, 8p a bunch at the time in Cornwall, and and my simple lesson of that is it's a bloody hard job, and it's a very unpleasant job. And I think when people go to Cornwall in the summer for their holidays, it's all lovely, but I can assure you the Cornwall in the winter can be a little bit inclement at times, and you're out in the field doing that, it's pretty horrible. And then with worker shortages, it's really, I think, initiated by national living wage, and then it was really Brexit which did it. Agriculture's running out of people, and it's also running out of highly skilled people like tractor drivers and all those sorts of things. And we are struggling to get people into agriculture, and so we're interested in two sides of the people story. One is the robotics element of it, because farms can't get workers, and two of it is the skills part of it. So how do we transfer skills and get skills levels up in farming, and but also try and get people into our industry in our world, particularly around agricultural engineering. So labour is a big issue, and it's not going away. I've just come back from a trip to the US. I met in Washington, British Embassy, met various people from the US, particularly Florida, and actually they're saying the same thing. Labour's a massive problem in US farms, and not least because of the current administration cutting off people moving across the border from Mexico, but also the same issues as us. It's hard to get people into our world. Then we got focused very much heavily on fresh produce, which is the third one, and again, really partly because of the labour story, because there's still an awful lot of crops which aren't slaughter harvested. And I was given some stats. I can't quite remember them, but it was something like 100 years ago. I think there was, I don't know, something like 50 workers per hectare on an English farm. And because of mechanization, tractors, combines, and stuff like that, that's now reduced down to a fraction of a fraction of a person per hectare. But in horticulture, in fresh produce crops, the number of people per hectare required hasn't changed in the last 50 years on the ones which are still manually harvested. So that's things like broccoli, that's strawberries, that's tomatoes and things like that. So virtually hardly any impact of mechanization over many years, and those are the crops which are highly dependent on labour. Now, but also from a diet point of view, we genuinely want those businesses to be successful, but we also want people to eat more and more fruit and veg. It's good, it's healthy stuff. And from my career at Marks and Spencer, what I learned was the biggest way to change human behaviour on food consumption is price. So one of the things what we got to do there is drive productivity so that we can get the costs out of production, but we've got to take the costs out of production so everybody still makes money. And that means productivity, and that's productivity to help the farmer, to help the retailer, and ultimately help the consumer. So productivity there is key, getting less for more, and that's what stabilizes prices, but also it enables people to buy more stuff that we want, particularly fresh produce and all those sort of good things. And then the third area we got heavily involved in at Lincoln was on the climate change story, and a friend of mine, James Brown, who's a farmer in Retford, who told me that climate change, yeah, it's a massive problem. He had, I think it was 2 years ago, he told me he'd had six one in 100-year climate events, but each in the last 6 years and all different. And that to me summarised the problem that it's got. It's now 2 years further on. He's now 8 1 in 100-year weather events, and it's not getting any better. And I think technology's got a real role in terms of helping farms to be resilient and manage their way through that. So why AgTech? Very important. And then this is also some of the key data. I think it's really critical that we just sort of reflect on where we come from. I think the classic one is the one on the left, which shows wheat yield, how that's developed from 1800 to 2050. And you can see until the Second World War, it was pretty well flatlined. And then it went up massively. And what you tend to find is a lot of people, it depends on their interests. So if you speak to a plant breeder, the plant breeder will say, well, it's all to do that steep uplift. It's all to do with plant breeding, and yeah, sort of. And or if you speak to a pesticide company, and it's not a radioactive chemical, but a chemical down the bottom there, they'll say, well, it's all to do with pesticides, and yeah, it is partly. Or if you speak to a fertilizer company, they'll say it's all to do with fertilizers and the Haber Bosch projects. Yeah, it is. I think the one that always amazes me is from an engineering point of view, which sort of frustrates me, is the one that people always forget is the massive expansion of machine power and size and scale. And machinery has been absolutely crucial. But in a lot of the narrative, it often gets forgotten. And I think it was 1954, 55, something like that, when John Deere started four-wheel drive machines. The deployed power from a machine has risen linearly every year on, year out, since the Second World War, and it continues to grow. So machines are just getting bigger and bigger. That's driving productivity. It's driving economics. It's driving scale, and it's also driving some sort of social and environmental issues. For example, need for bigger fields and compaction and all those sorts of things. But the thing that is generally forgotten is engineering, which frustrates me. But it's definitely been significant. And now, but what you can see there is since about 2000, we've had this flat line, and you've had a lot of yield variation. So it's bouncing up and down very rapidly. And we're not really certain why that is. Climate is a big one, but it's basically the flat line. So have we leveled off? I think the answer is probably we have flatlined, but there's more potential. So in Lincolnshire, I think the highest yield is 16 tons per hectare. So it's double the 8 where that's flatlined. So there's definitely a lot more to go if the circumstances right, soils are right, and the climate's right. So I don't feel defeated by that flat line. But the one on the right's important. It's total factor productivity. So that is outputs divided by inputs. It's all UK ag, so it's not just wheat. So it's not a like for like. But what we can see there is that has really risen steadily since the 1970s, and it's still going up. So we are still getting productivity gains through agriculture, and those productivity gains are going to be from innovation, changes in farmer behaviour, changes in economics, changes in food pricing and stuff. But the point is, if yields are flatline, we're still getting an increase in total factor productivity. We have to keep going, and innovation's absolutely critical and one of the lifebloods of modern agriculture. So what do we do at Lincoln? When I started in Lincoln, we founded LIAT in 2015-16, and when I founded it, I wanted to do something very different. I was given a blank piece of paper by the vice chancellor at the time. She said, just go and do good things and give us a good footprint in Agri-Tech. So I started really with 4 people when I started, and I wanted to do something very different. And what I knew from my farming background, particularly working really with my father, I think, on the family farm, I learnt about the amazing skills that farmers have to do their day job, and how I think a lot of people misunderstand the skill set and diversity of skills that's required to be a farmer. So if you're a farmer, the way that the UK government research side typically thought of farmers was as biosciences, and when Silso was sadly closed, which I think was a epic disaster for UK PLC, the whole of engineering, agricultural engineering, sort of disappeared a bit, and it was managed by the BBSRC, so the Biological Biosciences Research Council, who of course took a bioscience biased view of the world, which is fair enough. I completely get that. But the reality is, if you're a farmer, you aren't just a bioscientist. What you're thinking on a daily job is you are an engineer, you are an economist, you are a manager, you are an environmentalist, you are a physicist, you are a chemist. You have an extraordinary grasp on a massively diverse range of interdisciplinary skills to do your job. So I would say incredibly skilled people. And just to give you an idea of the science diversity we've done at Lincoln, we've now got projects done and ongoing, which have had 50 different science disciplines involved, 50 different science disciplines to try and drive forward agricultural technologies. But also, if you're doing Agri-Tech, you need a pretty damn good understanding of the agricultural system. You've got a good understanding of the supply chains. You've got to work with civic society, particularly more and more on planning and stuff like that. You've got to work with policy, so DEFRA. You've got to work with other farmers. You've got to work with supply chain, food industry, and it's a global play. So what AgTech does, and when I started LIAT, was not to do just a standard research group that just thought about either agricultural engineering per se, or bioscience, or agriculture. I wanted to do something different, and so what we set up was a small group, and it's what's called an interdisciplinary science group. So we have a relatively small team still. It's about 18 members of staff. Those members of staff, I select them particularly because they're good at networking, and I want them to be working with farmers, I want to understand the problems, and I want them to bring people together to solve really complex problems that can't be solved by individual people. So it's truly interdisciplinary, and that's what we've done. So LIAT does interdisciplinary research. We find problems, and then we put teams together to solve them. And then the interesting, we get funding from all sorts of places. So there's, I think, 8 UKRI research councils, and we've had funding from 7 of them. The one I haven't got is the arts and history one. We'll have a go at that some stage. But the interesting thing is when you do the interdisciplinary thing, all of science is connected to food, and all the science actually is connected to agriculture. They've all got an opportunity to fund in that space. So it opens up a massive funding opportunity for Agri-Tech. And then it's about matching sector needs and technologies. So we spend an awful lot of time to farmers trying to find the problems. So they want stable, resilient profits, secure skilled labour, high productivity, resilience to shocks. Resilience is an interesting word. The whole story isn't, in my view, about resilience. There's been an awful lot of talk about resilience from Oxford Farming Company conference, NFU conferences, you're talking about resilience, and it's fine. I get it. I mean, to me, it's resilience is about sort of holding on and staying in the same state. But I think the fantastic thing about farmers is they're unbelievably adaptable and innovative. And what you tend to find is through difficult times, it's not about holding on in farming, it's the innovators who seem to go forward. So I think that's the exciting thing about agriculture, is the innovation pace that goes on. It's about how people adapt to resilience. And then we're interested in sustainable practice, stuff like that. And then if you think about the technology solutions, there's a massive opportunity in all sorts of technology solutions to mitigate some of these problems. So we're working on AI decision support systems, digital platforms. We don't work on genetics, but colleagues elsewhere do. We work a lot on robotics, machinery, autonomy. There's stuff going on precision breeding, which is really exciting from the as a consequence of the Precision Breeding Act. A lot of stuff, we do a lot of stuff on new production systems. I'm particularly interested in glasshouse engineering still, and energy systems. A lot on data. There's still a lot going on crop protection. Circularity, I think, is really exciting. How do we reuse particularly in terms of nutrition, how do we find uses for waste products so we can use them as fertilizers? Whole systems analysis, I think, regen ag. So there's a massive opportunity in this space, and this is I think the exciting thing about what we do. There's lots and lots and lots of opportunity. So this is short videos. There's a few clips that some of you might have seen before, but this is sort of stuff that we do at LIAT. This is our site at Riseholme. We've been very busy working on crop breeding. This is a phenotyping robot which wanders up and down wheat plots and can identify new yields. We work with this company Saga, help found them really. So they've now got 200 robots worldwide, treats strawberry crops UV, stops powdery mildew. Had about $40 million of investment. It's one of the heroes of agri-robotics. We've got a new company now, Jabas, which is for crop logistic robots. So it's an autonomy stack which can move in and out of tunnels. Picker can call a robot. Picker puts fruit on the robot and does that. And that's a new company we founded about 8 weeks ago. And we're busy founding lots. And this is the stat working. We've got quite a big focus on safety systems. You can see a human coming around that corner. The robots pick them up, and he's dealing with that person in real time. And some of the work we do is closed. So the autonomy stack now we're closing off, but we're now releasing a whole set of human safety software to help robot companies identify people. This is another company we've done. It's FRUITCAST, which is AI for crop forecasting. So camera we can now image 3.6 million strawberries a day. We do a micro forecast for each strawberry. From that imagery, we can tell the age of each strawberry. We know when it's going to ripen according to the temperature, and off you go. And then it's the final one we've just launched, which is Agaricus, which is mushroom picking. So this is live from one of G's farms, G's Fresh Farm at LMF in Cambridgeshire, and we're pretty well up there. I think world leading performance in terms of pick rates, and we're just trying to commercialize this company at the moment. So if anybody wishes to invest, give me a phone call at the end of it. And then we do some fun things as well. So this is we've got about 110 PhD students we've been organizing across the country, 50 at Cambridge UEA on robotics, and this is one of them who decided to do this. And we've got a Boston Dynamics dog, bit of sheep herding, and I love this video. And look at this sheep when they look at this thing, and they're all going, what is that thing? And that's not a sheepdog. And but they're showing the same instincts to that robot dog as any sheepdog. Here they go, oh, I'm gonna leg it, and there's a robot going across, and we were interested in the behavior of the animals relative to the robot in this experiment. So we do some fun things too. I mean, the good thing about this one is I think sheepdogs are pretty safe because the batteries in that thing only last about 40 minutes. So I reckon Shetland dogs got a lot more robust, a lot more stamina than that. And then the other thing is, then how do you create these companies? So we created a number of startup companies already, and so we try not to be a standard research group that does a project, writes a publication, celebrates success, and then goes on to the next project. We like to really try and hammer it home, and if we can, we want to commercialize as much as we possibly can. And 2017, with Ian Thomas at Cambridge, I founded a program called Ceres Agri-Tech, and that's about translating basic science from the UK through to industry, and it's sort of addressing that eternal frustration about why UK is brilliant at generating fabulous ideas, but pretty rubbish. Doesn't have a great track record for commercializing it. It's not entirely the case, but I think we've all can remember and see examples where you think, oh, well, that was done in the UK, and then we lost it elsewhere. So we're trying to sort of look at that, particularly around agriculture and agri-tech, and we have this program called Ceres, and what we do there is we work again very close with industry, look for problems, and we then put teams together, interdisciplinary teams again, to solve them. And what we're finding is one of the reasons for failure in translation is that a lot of ideas might come from single labs, so a single individual, but that idea will never get anywhere unless that person can collaborate with others to actually accelerate it and get it to industry. So an invention in the lab on its own is all well and good, but it needs a big team to take it forward. That team might be other people from other science disciplines, or it might be people with commercial knowledge, business running knowledge, like people in the supply chain. It might be quite international people. So we do this translation. So we have ideas, we put teams together, and then what we do then is fund these people. We fund them under commercial terms, almost like a venture capital term. We'll give them the first £250,000 as a grant where they can prove there's a potential for a business or a license, and then if that's going well, we can then put in another £250,000 as a convertible loan note to start the company, and then we let them go, and then you put the team around them to help grow those companies. So so far we've had about £16.8 million in Ceres, and our latest objective now is to try and turn that into a venture capital fund to try and keep more agricultural engineering, more agricultural technology coming out of labs and getting commercialized. And we found there's sort of an interesting cultural thing in academia. We found a lot of people in the way academia works want to do this sort of open innovation stuff, which is fine. So they'll do stuff and publish it, which is absolutely fine, nothing wrong with that. But actually, my own view is if you really want to have an impact and you want to make a difference to the world, the best way, in my own opinion, which is biased, is to commercialize it. And because people make money out of it, they'll take it, it becomes self-sustaining, and then people get it, and then it scales. And that, in my way, is a great way to do impact. Nothing wrong with the open innovation bit. And then we found the projects in three ways. So you work with the problem, but sometimes you get you get ideas from an academic. So I've got this brilliant idea to solve this problem. Can you help me commercialize it? That's fine. We do a lot of what I call horizontal transfer stuff, and there's more on that going on around defense at the moment. So dual use technologies where you go, okay, well, that widget which is developed for let's just say it's the defense industry, has got a great interest in agriculture, so we'll port it into agriculture, or sometimes we'll port stuff out of agriculture into other industries. So that's called horizontal transfer. And then the bit that's probably the most fruitful is where we found the projects where people come to us with a really horrible, difficult problem which no one solved, and then we'll put a team of people together who probably don't know each other, and get them working on a solution. That's called Foundry, and it's probably the most fun and I think where we get a lot of our value add. And then we've done all sorts of stuff. So these are some of the projects. We funded about 60 projects so far, anyway, from nitrogen runoff capture, direct air capture, bio-based batteries, cycling distillers grains, biopesticides, herborite fertilizers. You can see they've all got a technical theme. That's environmental impact. And this is the stuff we do in robotics. This is dear to my heart. It's the one I lead. And so we've got projects on automated lettuce harvesting, blackgrass detection, sensor technologies for potato stores, fruit picking, mushroom picking, which you've seen, 5G, navigation, potato grading, you name it. I think the thing about the last two slides is just shows the diversity and the opportunity. So let nobody say there is no opportunity for innovation in this space. There's huge amounts of opportunity. I think the challenge is priorities and how we prioritize it. We're also sort of working very closely. We work very closely regionally. So I think it's something. I think if you look at Lincolnshire particularly, it's got an exceptionally high density of agriculture. It's got 30% of field veg, big chunk of sugar beet, big chunk of cereals in the county, and a lot of food processing. And what we're trying to do at Lincoln is really make sure we've got a research group in the middle of the county to try and drive social value within the county. And one of my frustrated issues I've had over the last 10 years is Agri-Tech and agriculture particularly. And if you look at the English ecosystem, we've got some great universities all over the country, great RTOs all over the country, but all highly dispersed. And what we're trying to do with Lincoln is create a new cluster in Lincoln, right in the middle of the county, but right in the middle of the UK is probably one of the most important agricultural areas. And then the idea is if you drive a cluster, and what I mean by that is to try and crowd in as many companies as possible. We're trying to get as many companies crowded in so that people then come join those companies, but they then stick in the region so that they then buy a house in Lincoln or outside Lincoln. They can move from company A to company B without moving house. They can have lives, they can have kids at school and all that sort of stuff. So we do an awful lot where we're trying to drive this sort of social value bit by creating companies in the region to make them make people stick in the region, and that's what drives social value and growth for the region. So I spend quite a lot of time involved in that. And then just my final slide before I hand back to Ray. UK AgTech still world leading for? I think it is. I do. I think Lord Willits and the AgTech catalyst, whenever it was launched, did a great job. He got that going, and you could argue about whether the program itself has been fully successful or not. But Ag-Tech, I think, is still important, and I look to some thought leaders. George Freeman, I think, has done some great work. He's got this 30-50-50 vision, and where he calls for a 30% increase in production, 50% reduction in environmental impact, and all by 2050. So that's the 30-30-50-50, and that's all through Ag-Tech. And I've got a high degree of confidence that we can do that, and if not beat it. We just got to work together and keep going, keep commercializing, and get these technologies out on farms. So I'm going to hand back, Ray, for questions. Is that all right?
Absolutely, yeah. No, thank you very much indeed.
Yeah.
Yeah, some really interesting points there. I mean, I just my thoughts on that, having been involved in the sort of a small part of the UK robotics ecosystem. I really like what you're trying to do in terms of that, taking that research piece and bringing it all the way through and actually getting it into a commercial, into commercial reality, and building up that cluster effect as well. I think, huge value in that. I'm just having a look to see if we have any questions in the chat. Here we are. So we have one from Mark Andrews. So, are you writing your own algorithms for AI, and how are you managing the safety related aspects of that?
Well, that's a really good question. I think the reality is it's very, very unlikely that anybody from an agricultural engineering bent will write their own AI algorithms in the truest sense. It's not impossible. We've got 3 or 4 professors of AI at Lincoln who work at it. I think the interesting area in AI is on the application side, and so if you want to be open AI and you've got several $1 billion, you can do the algorithm bit. But actually, from a very practical point of view, what we're trying to do is really look at the application side of AI. And so that's every single robotic system that you saw there is AI enabled. And so AI is absolutely everywhere. And it's probably a much higher adoption rate than most people feel. And I went to, it was a farm show. It's about 6 months ago, and it was at Cranfield, I think. And I went into, it's about 150 people at the event, and there were about 15 companies with booths. And I went around each of those companies. They're all engineering companies, and 7 of them were basically selling new AI enabled technology. And I would bet, if it was this year's show, 10 of them would be selling an AI enabled technology, whether that's machine learning, machine vision, a control system, maybe, or it might be something that's designed with AI, which is then applied in a conventional way. But it's everywhere. And I don't think it's, I don't think we're going to, it's, I think that acceleration rate is going to keep continuing. Yeah.
So I've got another question in. So, what, if any, are the gaps you consistently stumble over with regards to the hardware side of things?
What we tend to find is, and just when working with startups, you tend to find a lot of startups who are out there, and you tend to find the gaps are usually where startups aren't co-creating their technologies with farmers, and where something doesn't quite fit, or something's not robust enough, or something that hasn't got proper engineering standards behind it. So the challenge, I think, is still there's an awful lot of startups out there who are pretty hopeful, who haven't done proper co-creation, and then you get all sorts of hardware problems and all sorts of software problems. And I think the thing that always amazes me is how operationally complex the farm environment is, and it's a damn difficult place to work for technology. It's I talked to a lot of robotics people who work in factories, which is a controlled environment. They've got heaters and they've got boxes to put their robots in with cages and stuff. Well, that doesn't happen in agriculture. It's really at the top end of hard what we're trying to do.
I completely agree with that. I think that's I find exactly the same thing when I we'll bench test something, and then we had this only a few weeks ago, and then we took the technology, jumped on a boat, went over to France, put it in the field, and then it just everything started to fall apart. There's dirt in the system. There's all sorts of different things. So I think I really agree with your point around making sure that you working really closely with farmers, or sort of co-developing with farmers. I've got a bit of a question, a kind of a follow-on from some of your comments when we spoke to you when Kit was over in California. So you were talking about the differences between the UK kind of Agri-Tech funding versus the US Agri-Tech funding. Are you seeing? It's kind of obvious there's a bit of a gulf there in terms of the difference between the two, but are you seeing a sort of an improvement in that situation in terms of the funding situation in the UK? How is that sort of playing out?
Well, the on both sides of the Atlantic, the VC market's been pretty dead for the last 3 years, but everybody's starting to say 2026 it's starting to turn a bit. So let's see. But there's no doubt if you go to California, the amount of funding coming in per project is about 10x what you'll get in the UK. And I think that's a very it's a classical thing. So it does actually have to, you do have to be very entrepreneurial in the UK because you're dealing with not a lot of money, and you've got to use it very wisely and very resourcefully. So you get a different behavior within startups than you will in California, where there's more money around. But there's no doubt the 10x thing to get scale really helps, and we are missing some of that in the UK. So we are starting to hear of some of the potential, and Kit and I were at the same event where people were mentioning the first IPO in agriculture for a long time, and that might be around some of the robotics companies. And the one which people are looking at is Carbon Robotics, which now got, I think, 200 machines worldwide, several of them now in the UK. And IAgrE Robotics in Switzerland, again, possible IPO. So hundreds of millions gone in there. There's IAgrE Robotics systems all over the UK, all over the world now, and that's happened in about 4 years. And part of that is that massive initial injection of cash, so they can get up to scale quickly. They can put more engineers in, they can do more tests, they can do more validations, get out more farms, and that massive cash injection, if it's used wisely, really helps. And we do struggle with that in the UK. And part of my frustration of that is one of the reasons we're kind of interested in trying to develop our own venture fund. Because there's people in the market, but the market, I think, I don't think it's failing, but it's not accelerating as quickly as it should. And so we're trying to actually think about how we solve that. And if it's not in the market, then create it. So that's what we're thinking about.
No, I think that's interesting. I think they're definitely for me two standout companies. Both had interesting backing as well in terms of the bigger companies that have backed them. Chemical companies or Nvidia that's backed Carbon Robotics. So I think that's interesting to see as well, that angle of commercial support.
Yeah, and watch this space. I think there's a lot of machines now coming in the UK, mainly around organics, I think. But you could see an IPO scale. If you did, let's just say carbon just stuck in organics. Well, there's an awful lot of organic farms around the world who need one of them robotics.
Yeah.
This, so it's the market might seem small, but actually, if you multiply it by a global thing, it's fast. No. Yeah.
We've actually had another question come in. So, where are your PhD students coming from, and who funds them? Is it overseas or domestic?
good question. Of the we've got two CDTs. Those are called Centres of Doctoral Training. They funded 110 PhDs, but by UKRI, UK Research and Innovation, which, as the name implies, they have quite a strict rule that a large proportion of students have got to be British or eligible for British fees. So that's I think that's a good thing. And then it depends on the university. So we've got a lot of those at Cambridge, and so you know that you tend to find that they're a archetype, and then you got then another group at Lincoln, which is another archetype, and we've got a group at UEA, which is another archetype. But the majority are Brits, and I think one of the things we've done is what I found is particularly young people, they're all inspired by food. They get food. So they all want to help solve the world's problems, invariably. And if you then say to them, well, you can actually help solve the world's problems and stuff like that, but you can get a PhD in an advanced engineering skill like robotics, it does draw them in. So we've used this food thing as the messaging as an attractor to try and get talent in. And I think that's worked. Now, the problem we've got is now making those people stick in our world. And so they do their PhDs. And then what we find is some very nice person from Apple rocks up and goes, here's a large amount of wedge. Come and work for me in Apple. And then some of the professors are going, hang on a minute, I'll go and work for Apple as well. Yeah, so money is a big attractor at that age, particularly, and it's quite a challenge of making them stick. And that, I think that's our next thing. So we can train them, but let's keep them.
No, I think that's again something I've seen from colleagues that I've had in the past when I was at a small robot company, and actually seeing the diversity in terms of when the company folded.
Yeah,
the ways in which they went. Some people stuck with agriculture and obviously kind of got the bug for it, and actually it wasn't some of the sort of the PhD candidates, it was the people actually out in the field, interestingly. So day in, day out, getting to know and getting a taste for being stood in the field and understanding things. So that's that. I always take that away when people say, oh, a small robot company went bust, but actually what came off the back of that in terms of the skill sets that
exactly.
left and stayed within the UK. So I think that's really good.
No, nothing's ever lost. You know, it stays within the people who got that skill.
Absolutely. I've got another question myself, actually. It just, one of the things that I get challenged about in the work that I'm doing, the sort of consultancy pieces, I speak to people working in robotics, and they always turn around and say, oh, it's all well and good, you know, I'm working on we're working on these robots, but no one's generated any standards to help me put the robot into the market. And I always come back with, there's lots of tools out there that don't necessarily have to be a standard, but it'd just be interesting to get your thoughts around the sort of compliance piece for that journey from prototype to on the market.
No, it's a really good question, and there's regulations and standards. So I did a big piece for the FSA last year on AI, and the question there was, do we want regulatory standards for AI applications in agri-food? And I think the answer at that time is AI was very early. No, thank you. We'll wait and see what happens, and then we'll think about it, because government doesn't really like to do regulation. Because it's expensive, it takes time, and usually it's too late and stuff like that. Standards, absolutely, and I think we are short of standards. So we had an interesting discussion yesterday on an innovate project where we've done some great work on safety stuff for robotic applications around people, so collaborative robots around people, and then and we're looking at 4 or 5 different algorithms for people detection, and then you do want to get that right, because if you get that wrong and then somebody's harmed, that's a serious issue. And then I think standards then are very important. You know, how do you test it? How do you validate it? How do you verify it? How do you certify it? And I think we're actually quite a long way behind there. I think it's been discussed for the last 3 or 4 years, but I just think we're starting to granulate now what the real questions are, particularly as the technology matures. And the great one yesterday was it was on a autonomous robot, and it was the safety detector, and how do you certify that that is safe around humans? Big question, and that's standards, I think.
Yes, yeah. My takeaway from it is always my first question is to ask someone if they've done a risk assessment, because
Yeah,
there's a
yeah,
there's a whole load of other work you could go away and stress about or think you haven't done. But if you haven't even done a risk assessment, you haven't even kind of built out a basis for understanding what in which directions you might need to go. So that's always my first piece of advice is, go and look up the standard
yeah.
go and look
You're
up the
right,
ISO.
and the risk assessment makes you be be very pragmatic as well, doesn't it?
Yeah.
You can get drawn into the sort of big theoretical world, but actually you tend to find with this stuff being early leading stuff, pragmatic approach is usually your first point of safety.
Absolutely. So we had another comment just asking about the slides. They will be, well, this presentation will be available online on YouTube eventually. So if you go to the IAgrE YouTube channel, that will be there. I don't think we've had any other fresh questions in. So I think we can probably wrap it there unless there's anything else anyone wants to ask or anything else you'd like to say, Simon.
No, that's great. No, thank you for spending some time to listen to me. It's great. So very happy to help. And if anybody wants to get in touch, just please do.
Yeah, I was going to say that is one thing. What's the best way for people to get in contact with yourself?
Straight email, spearson@lincoln.ac.uk.